Hi, welcome again to metrology lectures. And the last time we did aliquot method of weighing and measuring small quantities. And so for this lesson, we'll be looking at least weighable or least measurable method. So the first one we're going to be looking at is the least weighable method, which is a well-known method that is used to weigh small quantities. So the example says a class A torsion balance has a SR or sensitivity requirement of 6.5 milligrams. Explain using calculations how you would weigh 15 milligrams of atropine with an error of plus or minus 5% using lactose as diluent. So the first thing that we're going to do is to determine the quantity of ingredient requested. And that ingredient is 15 milligrams of atropine. Now, the second thing is to determine the least weighable quantity for the balance that you have available to you. Because we were given the sensitivity requirement and the expected error, we use the equation as listed here to determine the least weighable quantity. And that is going to give us 130 milligrams. What this means is that to weigh anything less than 130 milligrams will increase the level of error, which is not what we would want. We want to maintain an error of plus or minus 5%, meaning that 95% of the time we are quite sure that what we're weighing is what we need to weigh. So we can't use the scale to weigh anything less than 130 milligrams. That means the 15 milligrams that is required cannot be weighed on this scale. Therefore, we're going to have to find a method to weigh this 15 milligrams. Now, step 3 is to determine the aliquot of a concentrated triturate mixture that will contain the 15 milligrams of drug. And the whole point of this is to allow the unweighable portion, which is the 15 milligrams of the drug, to be contained in a weighable portion of a concentrated mixture. Traditionally, this aliquot is usually the least weighable quantity, or it could be more. So we're going to let 15 milligrams of the drug be contained in 130 milligrams of triturate. We are going to let that. We are going to make that statement. So from the onset, the amount of drug that we want to weigh, we're going to let it be contained in a portion or an aliquot of a known mixture or triturate. Next step is to select the amount of drug to be weighed. Now remember, we can't weigh 15 milligrams. We can only weigh 130 milligrams or more. So we're going to select what is it that we're going to weigh. So we're going to weigh 130 milligrams, which is the least weighable amount of the active drug. This we know that can be weighed. Why are we weighing 130 milligrams? Because we can't weigh 15 milligrams. I can't overemphasize that. We are choosing what to weigh. And the mere fact that you're choosing to weigh 130 milligrams, which is equal to the least weighable, makes this method the least weighable method. Okay? Note that the amount of the drug to be weighed need not be the least weighable method, but an amount that will maintain the acceptable range of accuracy and precision. That is, we can weigh more than the least weighable quantity. However, if we weigh more than the least weighable quantity, then it means it won't be the least weighable method, right? But that does not mean it's not accurate. It just means that you are not weighing the least weighable amount in terms of the amount of drug that you're weighing in order to make your concentrated triturate or mixture. And there are instances where you are going to require to weigh more than the LWQ. The next step is to determine the total amount of triturate mixture to be made. And this triturate mixture is going to contain the total amount of drug that you are going to weigh plus the diluent. You mix those together to form your triturate or your mixture. And from that triturate or mixture, you're going to remove an aliquot or remove 130 milligrams, which will contain the 15 milligrams, because that's a statement we made at the onset. So since 15 milligrams of active drug, we want it to be in 130 milligrams of aliquot, then the 130 milligrams that we can actually weigh now, we need to determine what amount of mixture or triturate will the 130 milligrams be contained in. Do a cross multiply and we get 1126.7 milligrams of total triturate mixture. So this means that we are going to have to determine how are we going to make the mixture. We are going to have to combine 130 milligrams of atropine with a certain amount of diluent to make the 1126.7 milligrams. So to determine the diluent, we subtract 130 milligrams from total mixture to get the amount of diluent that we need to add to make this mixture. So atropine is 130 milligrams, and the diluent, in this case it would be lactose, will be 996.7 milligrams. So this means that I'm going to take 130 milligrams of atropine. I'm going to weigh it. I'm going to mix it with 996.7 milligrams of lactose, mix them together to form a homogeneous mixture to get 1126.7 milligrams of total mixture or triturate. And from that triturate, I am going to get 130 milligrams, which will contain the 15 milligrams of drug. So this simply means that the concentration of this mixture, which is 130 milligrams divided by the total mixture, which is 1126.7 times 100%, is 11.5%. And that suggests that if you make a mixture of concentration 11.5%, then you should be able to remove 130 milligrams of that mixture that will contain the 15 milligrams of atropine that you need.